Assalamu alaikum everybody. Welcome to Practical Numerical Methods for Scientists and Engineers. And today we have we'll continue with module 4 for roots of system of equation. And today we'll start with one numerical method. It's Cramer's rules method. Cramer's use matrix determinants to solve system of equations, provided that the same number of equations are variables. So let's start how to determine the determinant of matrix. If you don't know, if you know it, please skip this step. If you don't know it, please keep with us. So if I have a matrix 2 plus 2 matrix, so I can find the determinant of A by A times B2 minus E2 minus B1. Okay, so by this, determinant of A equal A1 times B2 minus A2 times B1. Okay, so as you can see, it's very easy for 2 times 2 matrix. It will be a little bit complicated for 3 of 3 matrix, and here we have 2 common methods. You can use any of them according to your convenience. So in method 1, if you have a matrix 3 of 3, so the first step, just put the following signs. The first column put it as plus, second column put it as negative, third column put as plus. Of course, if you have more, you can plus and minus. Okay, but we'll start by 3. Okay, so first step, we will have 3 types of equation for this one. So we'll start one by one. So we'll start by the first one. So here we will cancel the first column and the first row. Okay, then you have only this one. So now you can find the part of determinant P2 times C3 minus B2 minus times C2. Okay, B2 times C3 minus P3 times C2. So this is the first part. Then we can go for the second part. For the second part, we can just cancel the middle column and also the first column. So let's see it. Okay, now we canceled. So now it will be A2 times C3 minus A3 times C2. Of course, for the last one, for the last column, we'll do it like this. So A2 times P3 minus A3 times P2. Okay, now we have 3 terms of equation. So just we want to make them like this. Remember that we put plus, minus, and plus. So this column is plus, this column is minus, and this column is plus. So the determinant of B will be the B2 C3 minus, this is the first part of equation, minus, because this one is positive, this one is minus, so minus A2C3 minus A3C2, and the last column is positive, so it will be A2B3 minus A2B3. So by this we can calculate the determinant B. I think it's, inshallah, you can find it easy. Okay. Okay, this is another method. Okay, so you can select any. Both should give you the same value because both are correct. So in this matrix, you can just copy the 2 columns and put them next to the first 3. So we have, this is my original matrix. Then the first only 2 columns, put them like this. Okay, then in this part, it's a little bit different. So we can multiply from the first left diagonal to the lower right diagonal. So it will be like this: A1 times B2 times C3 plus B1 times C2 plus A3 times C1 times C2 times B3. Of course, we can't take both because there are two, and this one, this also two, this one, so we should be a combination of three items. Then, so all of them are plus, 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 plus. Then minus the left from here, from the left, from the lower left to the upper right, like this. So minus, sorry, like this. Sorry. So A3 times B2 times C1 minus P3 times C2 times A1 minus C3 times A2 times B1, or you can minus and combine all of them like positive. So this will be our final shape, and this will be determined. Both should give you the same result, so you can use any one that is convenient to you and faster to do the calculation. So in the same way, Cramer's methods can be used to find the determinant of x, y, or z by replacing the column with the constant column. Okay, so now how to do it? For example, you already found the determinant for the matrix. Okay, this is the whole matrix. Okay, and you want to find the x matrix. So just you can replace, so you know, x1 in the first column, and x2 in the second column, and x3 in the third column. So you want to find the determinant for x1, so just remove this one and replace it with the b. Okay, with the b. So you have a1 plus a1 x1 plus a2 x2 plus a3 x3 equal b1, and here you can continue. So this is the b1, so you can take this column and replace it here. By this you can find the determinant for x1. Okay, so let's take an example to make it clear. Use Cramer rule method to determine the roots of the following linear equation. So, and this is my equation. I want to use Cramer method. So first, I will create a matrix of 3. Okay, so this will be the first one, second column. This will be plus. This will be 1. Okay, and the same, and here's also the same. Okay, and then find the d. This is d of the matrix. Then after that, for the first column, to find the matrix of x1, so just we create a similar matrix, but instead of putting this coefficient, we use this one instead, and then that's for x2 and x3 it will be the same. So let's check it now. This is my d, so it will be 0.3, 0.521, okay, 521, 1.9, okay, and then we, by either using the previous two methods, we found that d will be minus 2.2 times a power minus 3. Now for dx1, just what we did, we kept both like in the same positions, but we replaced the first column by the free ligand, or the free coefficient. Okay, so the dx1 become 0.032. Okay, then after that we can find the x1 values, okay, by division. So x1 equal dx1 over d. So if you divided dx1 over d, it will give you the value of x1. Okay, so we can do the same for x2. So we only replaced this one in the second position. Okay, and for dx3 we replace the dx3, and in all cases we find d2 and d3. So by this we can find x1 equal dx1 over d3, dx2 x2 is it's equal to dx2 over d, and x3 is dx3 over d, and hence there are my values, okay, for x1, x2 and x3. Now if you are using this Cramer method manually, okay, so one quick way to find it, you can use the user calculator to determine the matrix determinant. Okay, so how to make it? Just go to in your calculator, go to mode 6, so it's matrix. Then you can go to for 1 matrix A. Okay, select 1 matrix A, and then insert of course you will choose your data, okay, 3 of 3, and then you can put your data, okay, in the matrix. After that, press AC. Okay, it's important to press AC to save the data in the calculator. If you didn't press AC, the data will not be saved. Don't press equal, press AC. Then after that, shift plus 4. So shift plus 4, it will go for this, this screen will be appear, and then press 7. So press 7, it's determined. Okay, then shift and 4. Okay, shift and 4, and the screen will be appear, because here you want determinant of which matrix. So you already saved the matrix, matrix A. So press shift and 4, and then go to for 3, select the matrix you already put the data in it, and then equal, so it will be mat A, and then equal, so it will show you the result. Okay, so it needs some practicing. You have to practice it, but once you practice it, you find it very quick and easy to use the calculator. You can use it to calculate or even to check your results, because sometimes you can do a mistakes while calculation by manual. So it's important to double check your data with the calculator. So if you found it different, then you can see what wrong you did in your data. Okay, now we can use MATLAB to find the roots of linear equation using Cramer method as following. How? So first, this script is to use for Cramer methods. First, we put A as a matrix, so insert the matrix of coefficients, okay, x1, x2, and x3, and B is also as input the right hand vector of constant. So we have the matrix, and we have the right hand vector. Okay, now here's det A, determinant A, so it will use to find the determinant of A. So this is the first step. Okay, now we want to find the determinant of each x1, x2, and x3. So here we want to replace the matrix, the first, for example, x1, replace it by this. Here we will use remember that we in the matrix we use how to replace and how to change the data. So we will use this feature, but it's important not to change the D, because if you change the D into the D matrix, so it will damage your data. So you want to keep the D as it is and create another D. So here we create another matrix, AX1 equal E. So this to create another matrix and keep the original one. Now we want to replace the first column with B. So AX1 is from this one, between parentheses, all rows and first column equal B. So it will change all the first column by B. So this is to replace the first column with constant. Then we can find now the determinant of AX1. So DX1 equal det AX1. So this is find the determinant of X1. We can do the same for the second and third x. For the ax2 equal 1 to create another matrix x2, then replace the second. Here we replace only the second column instead of the first one, and then find the determinant. And here we replace the third one and find the determinant. Then x1 equal dx1 over d, semicolon ax2 equal x2 over d, and x3 equal dx3 over d. Then if printf parentheses, the roots are x1 equal, and put a value here, x2 equal, put a value here, x3 equal, then put x1, x2, and x3. I think now you can find it very easy. Once you understand the logic behind the MATLAB codes, you will find it easy. You can modify, you can do whatever you want. So that's all Cramer method. Thank you so much, and see you in coming session.